Hello, welcome to our video solution for problem 3 from Superquiz 1. So here we're really just examining the definition of a relation and a function, and we can see in the last bit an injective function. So you recall in class we wrote down this very abstract definition of a relation. The reason we wrote it down abstractly, right, being that it's actually a useful mathematical definition. Right? Instead of having to talk about, well, it's a rule that associates to each element in one set, an element in another set, blah, blah, blah. We instead can write down something very precise, namely when you have a relation between or from a set S to a set T, it's just a subset of the Cartesian product, which you'll recall is all pairs of elements of the form S comma T, where S is in S and T is in T. Okay, so a relation is just a bunch of pairs of elements from one set and another in a specific order. So the first question here is asking what condition will need to hold for this relation to be a function. So a function, the key idea is that for each input into the function, you want to have a unique output. So the thing you're trying to avoid, right, is say something like this, where for a particular input, some x, you have actually two different outputs. All right, so if you're working in the plane, usually people talk about things like the vertical line test, right? You want to be able to draw vertical lines, and they shouldn't hit the graph of the function in more than one place. Of course, when we're dealing with arbitrary sets, there's no notion here really of a graph in the traditional sense, so we just need a more pure, precise definition. So let's say we have a relation R. So a relation R is a function, okay, if for all S in S, okay, so for all of the first component positions, there exists a unique output. Okay, so a unique T in T such that the pair S comma T is in R. Okay, so once you've chosen the first position, you don't have any choice about what goes into the second position. Right? And there's really two things being said here. Okay, there exists, that's the first thing, there is a T, right? Which this is what we mean by saying that S is in the domain, right? Is there is going to be an output of the function. And then the second thing is it's a unique T, right? You're not going to have this problem of a single X yielding two different outputs. Okay, so that's our definition for a function. Now the follow-up question here is, well, what about injective? And of course, I put this in here because so often people mistake the definition of being a function with that of being injective, particularly if they're using this phrase one-to-one. Right? So a lot of people say, oh, it's one-to-one. You see, look, for each one S, there exists exactly one T. But that's not at all what one-to-one means, right? So it's kind of what it sounds like it says, but it's not what it means. So we have to remember that being injective, right, is a codomain condition. And I'll refer to you to my other video on injectivity for more details on that. So let's say a relation or function now R is injective if, well, so this is where we basically turn this phrase around. Instead of for each T, or for each S there being a T, now for each T there is going to, well, maybe not necessarily exist an S, but if one exists, it's unique. Okay, so if for each T in T, there exists at most one S in S such that S comma T is in the relation. Okay, so this doesn't mean that everything in T has to be hit by something, right? For each T in T, there could be nothing that goes to it, all right? But if there is something that goes to it, there's only going to be one thing that goes to it. Okay, so this is our definition of injective. So from a pictorial point of view, let's look at these two. Again, if you have an S and a T, for part A, what we're saying is that from each dot, you need to have exactly one arrow coming out of the dot. For part B, we're saying for each dot in T, there needs to be at most one arrow going into the dot. Now, as you notice here, I don't have any arrows going into these dots. That's totally fine for injectivity. What I'm not allowed to have is a second arrow coming into this dot. That would be no bueno for injectivity.